Okay, today we're talking about transforming and combining random variables. This is the first lesson of 6.2a. If you paid attention, one of the first chapters we did, maybe chapter 2, I'm not sure, these principles should be very familiar to you for sure. Okay, in fact, that's how we're starting, right? We're starting with, if you remember, when you add or subtract a constant to all of the data values, we had a list of numbers and we added 5 to everything or something, then how does that affect the center or the variability at the measure of center? So does not change the variability at all. The spread is still the same, but it does change the center, and it does not change the shape at all. At multiplying or dividing by a positive number does change both the center and the spread, but does not change the shape. So those are just, if you just kind of just look at that screen, that's stuff we've already learned that will help you hugely. It's just a slightly different setting, but those principles are still basically true. So we're just looking at a slightly different setting. So we're talking about random variables here. So PhD tours, you're familiar with that example here. They offered a day trip. C is the total amount of money that they collect for the trip, right? So, and we've seen this data before. If it costs Pete $100 to buy permits and pay for gas and a ferry pass for each trip, so it really doesn't matter if you have 2 or 6 people on the trip. The cost for him is $100 every time. It's just the same cost every time. So it's pretty easy to figure out. So V is the amount of profit. So you're basically going to take it, how much money he takes in, minus the cost will be that profit. So V, or the profit in this case, is going to be the amount that he takes in minus the $100 cost that was there. So for some reason we use C for money collected. That seems like cost should be that, but whatever. Okay, effect of adding or subtracting a constant. So what's going to happen if we subtract a constant? So how does that affect the mean or the standard deviation of the data? So the mean was $462.50, or it was $562, but it's going to be $100 less because it is affected by subtracting, the center is. However, the standard deviation is unaffected. If it was 163.46, it's going to stay 163.46. So it doesn't change. And the shape, you can see the shape of the two. I like that they show both of them there. Shape's the same, right? I mean, the numbers are slightly different, but as far as the shape of the graph, they're both approximately symmetric kind of a thing. So the shape is the same. They have a different center. Effects of adding or subtracting a constant on a probability distribution. So adding A changes the measure of center, whether it be the mean or the median or whatever measure of center you're using. It does not change the measure of the variability. So range, IQR, standard deviation, those are all measures of spread or variability there. So it doesn't change the spread, it just changes the center, doesn't change the shape. Same concept here. Adding, subtracting constant affects the distribution of a quantitative variable and the probability distribution of random in exactly the same way. So that the principle is the same. So this should be an easy problem if you understand the principle. Let's see. In a large intro to stats class, the score X of a randomly selected student on a test worth 50 points can be modeled by a normal distribution with a mean of 35 and a standard deviation of 5. Due to a difficult question of the test, this nice professor decides to add 5 points to each student's score. Let Y be the scaled test. So the scale was to add 5 to everybody. Pretty nice. So describe the shape, center, and variability. So how would that affect, say, the shape? So adding 5 to everyone's score, will that affect the shape? Not at all. Will it affect the center? So the mean was 35. If you add 5 to everybody's score, the mean's certainly going to change. Adding does change the measure of center, so it's going to be 40. How is that going to affect the variability? It was a standard deviation or a spread of 5 there. It's still going to be a standard deviation or a spread of 5, so it doesn't change the variability. Effect of multiplying or dividing by a constant on a probability distribution. So again, just a slightly different setting, but multiplying affects things just like it did just a group of data. So multiplying or dividing, essentially, does change the measure of center. All the measures of center would change. It does change the variability, so it spreads it out more. So it is more spread out if you're multiplying by a number bigger than 1. It's going to be more spread out. It's going to change the variability, but it won't change the shape. So in either case, adding or multiplying doesn't change the shape. So that's just going to stay the same. It has the same effect that it did on just a regular group of data. Okay. El Dorado Community College considers a student to be full-time if she or he is taking between 12 and 18 hours or units. The number of units X on a randomly selected El Dorado Community College full-time student is taking the fall semester has the following distribution. So that's a nice, probability distribution there that's shown. You can see that most students, 15 is pretty popular. There's some students who take 12 and some that take 18. So at the right is a histogram of the probability. Oh, that's a nice picture of it. So the mean is right near the middle there, 14.65. Standard deviation of 2.056. So typically, deviation from the mean of about 2.056 hours or units there. The tuition for a full-time student is $50 per hour or unit. That is, if T is the tuition, then T equals 50X. So it's $50 per hour. That's, I think, pretty cheap for school. It's community college. That actually makes sense. So they charge pretty good rates there. So what's the effect of multiplying every single value there in the distribution by 50? What does multiplication change the center of spread? So what shape does the probability distribution have? So it's going to have the same shape, right? Trimodal. I mean, what is that? But it's not going to change. It has 3 peaks, I guess we say, the same shape as the probability distribution of X. Find the mean. So the old mean was 14.65. So the new mean would be 14.65 times 50. The old standard deviation was 2.056. We're going to multiply that. So multiplication does affect standard deviation. So you're going to multiply it by 50 to get 102.80. Effect of a linear transformation on a random variable. So this is, again, similar concept. This is where you're maybe adding something, A, multiplying something, B. And so if you do both things, what happens? How does it affect things? Has the same shape, no surprise. They're saying that B could be negative, but if you're multiplying the standard deviation is never really negative, so we're gonna multiply by the absolute value B. So that's just a slight little detail there that could come into play, but you're not going to have a negative standard deviation. So just never put a negative standard deviation, and that will make sense to you that you won't use. If B is negative, you won't use the negative in that case. You'll take the absolute value of B. To both discrete and continuous random variables. So that's nice to know. Okay. We're going to combine some random variables here. So Pete has a sister that also runs Jeep tours, competes with him, I guess. So instead of working together, they have a separate business. She has different proportion of folks who ride in the tour than he does. She has 5 as the max. Maybe she has a smaller Jeep. What is the sum of X plus Y? X is the number of passengers for Pete, Y is the number of passengers for Aaron. So you're adding those up, or the difference between the two on a randomly selected day. So the formula is what you might expect, actually. So if you're talking about the combined mean there of the two, if these are random variables, the mean of the sum of 2 random variables is equal to the sum of their means. That's probably logical. It's probably what you would have thought, and it is the case here. Same thing for differences. So let's just see how it works here. So Pete charges $150 per passenger. Aaron charges $175. Let's see the amount of money that Pete collects, and E is the amount that Aaron collects. From our earlier work, we know that they have means of those. Define S equals C plus E. So we're we're adding up the amount of money that he collects and the amount of money that she collects. So can we just add those numbers up? We absolutely can just add those numbers up. So we don't have to do any special calculation. It's just 562 plus 542, 50 each, and there, add it up and you get it. Pete and Aaron expect to collect a total of 1105. Remember, expect means the mean. On average, that's what they're collecting. It doesn't mean any day they're actually collecting that, but on average, over many randomly selected days, that's what they're collecting. Let's just look at a few examples. I think y'all might be getting it now. Again, it's just reinforcing a concept that we had earlier in the year. So I like that about stats. We constantly come back and reinforce concepts, I feel like, and use them in different settings, slightly different settings. A large corporation has thousands of employees. The distribution of annual earnings for the employees is skewed to the right, with a mean of 68,000 and a standard deviation of 18,000. Because business has been good this year, the CEO of the company decides that every employee will receive a $5,000 bonus. That's awesome. Let X be the current annual earnings of a randomly selected employee before the bonus Y, be the employee's earnings after the bonus. Describe the shape, center, and spread of the distribution of Y. So after we add the bonus, we're adding 5,000 to everybody here. So what's that going to change? It's going to change the mean. The old mean was 68,000. Everybody gets 5,000 more, so it's going to be 73,000. The standard deviation was 18,000. Does it change when you add a value? It doesn't, right? So it's going to remain the same. Variability stays at 18,000. Doesn't change when you add a value. Adding doesn't change things. Okay. Employees selling refrigerators in an appliance store make money on commission based on how many refrigerators they sell. That's probably true. The number of refrigerators are sold in a randomly selected hour has the following probability. Wow. So one guy, well, pretty rare to sell 5 fridges in an hour, but that's a 2% chance. 0 is 22% chance, and somewhere in the middle. So they're doing okay if they're selling at least a fridge an hour, I guess. Here's a histogram of the probability of distribution at this appliance store. So on average, the folks sell about 1.72 fridges an hour with a standard deviation of typical deviation from the mean of about 1.36. So at this appliance store, the commission earned is $30 for each fridge sold. That is a C. The total commission earned for a randomly selected hour is 30 times R. So we're multiplying. In this case, we're multiplying the 30 times R. So what shape would this new distribution have? It's going to have the same shape as the original there. I guess that's skewed right. Bimodal, I mean, it's a strange one there. Find the mean of C. So the mean of the original is 1.72. So if we multiply by 30, you're going to take 1.72, multiply by 30. Standard deviation, you're also going to multiply that. This spread is going to be much more spread out there. So you multiply that by 30 as well. I guess I keep saying bimodal, but maybe I could say 2 peaks there. That's probably better to say. Although bimodal seems okay as well. What z-score did I get? Analyzing the effect of transformations. In a large introductory stats class, the distribution of scores over recent tests follows an approximately normal distribution. A lot of tests do that, with a mean of 82.4 and a standard deviation of 5.1. Okay, so it's kind of a tough test. 82.4 is the average, and the standard deviation is 5.1. So if you got about 93, you're getting unusual. That's more than 2 standard deviations above the mean there. Let X be the test score for a randomly selected student. To test the student's grasp of the material, the teacher cleverly decides to convert all the scores to z-scores and then report these values to the students. What a clever professor. If Z is the z-score for a randomly selected student, it's good to review this, right? The z-score is the value minus the mean over the standard deviation. So that's the basic formula. So this is kind of like we were talking about with the A plus BX transformation, kind of that we're subtracting and we're dividing, right? So how does that affect the mean? Do both things affect the mean, subtracting and dividing? And both things do affect the mean. So you would take the mean, which was 82.4. Let's see. Find the mean of Z. So 82.4, it just confused me. I was like 82.4 minus 82.4 over 5.1. So the mean the mean z-score, because I was like, what does it make sense? Oh, that's the mean z-score. So find the mean z-score. So the z-score would be 0 of the mean, right? That actually kind of makes sense when you think about it. I was like, why is the mean 0 now? That seemed very strange until I realized it's a z-score. The mean is in the middle of that, so it actually kind of makes sense that the mean is 0. Okay, interpret the standard deviation. So what would you do? So if you subtract, 80, subtract a number, does that affect standard deviation? No, but dividing does. So you can take the standard deviation of 5.1 and divide by 5.1. It's a standard deviation of 1. That actually makes sense because what is the mean and standard deviation of a z-score? The mean is 0, the standard deviation is 1. What a strange question. So if many students are randomly selected, the z-scores will typically vary by about 1 standard deviation, because that's what a z-score is, from the mean of 0, which is the mean of z-scores. Interesting. Hoops Fever is an arcade basketball game in which a player has 60 seconds to make as many baskets as possible. Morgan and Tim play head-to-head every Tuesday. Love it. M is the number of baskets made by Morgan, and T is the number of baskets made by Tim in a randomly selected match. Based on previous matches, we know that Morgan's average is 39.8, and Tim's, not quite as good, average of 31.2. So we let that D equal M minus T. So we're subtracting the two things. How do we find the mean of D? Well, we just subtract their means. So it would be 39.8 minus 31.2, boom. 8.6 baskets is the difference between Morgan and Tim, and the number of baskets made would be 8.6 on average of randomly selected matches. It's the difference of the number of baskets made. So that's the lesson for today.